Okay, today we're gonna get back on the road to actually doing the Laplace on some functions. We're not yet at the differential equation level, but we're Laplacing a function, which is this. These steps are necessary to get to the other level. Okay, so our example today is evaluating. By the way, we got a better camera. Can you tell? Okay, we improved our camera situation. It was a little issue, and now it's resolved. Hopefully, the first two videos in this series are, are not too bad for you. Okay, we're going to evaluate the Laplace of a t. Since we ended the last video talking about a t to the n, well, in this case, it's a t to the 1. And I guess you could just extend this further if you want and do a t to the 2 or a t to the 3, but at least we're starting off with a t to the 1. So the f of t here is t. And by the definition 7-1, taking the Laplace of t, okay, is from 0 to infinity e to the minus st times the f of t. So there's your definition, okay, right here. And now you're saying, well, that's equal to 0 to infinity of e to the minus st times t dt as you insert your f of t into the integrand. Okay, so then we find that we can pull the limit out. It's the limit of b as it goes to infinity uh, in front of the integral. And then we're going from 0 to b of e to the minus st t dt. All right, and recall we're treating s as a constant always during these integrations. Okay, treating s as a constant, so it's not we're taking things to the parameter t and integrating and all that, and s is nothing more than a constant. All right, so as with a lot of these, you're going to find when we're doing the Laplace, you're going to need to review how to do integration by parts. Okay, so it's the integral of u v prime dx equals uv minus the integral of v u prime dx. All right, so there's the integration by parts formula. And we start out with the thing that's going to, we're going to differentiate the thing that's going to disappear as quickly as possible with successive derivatives. And that in this case would be the t. Okay, so if you did a second derivative here, you'd have 0. So in other words, you need this thing to disappear over here because the e is just going to keep going and going, and then eventually you could end this guy with integration by parts at some point if you do if you allow u to equal t. Okay, so we're allowing u to equal t. We take successive derivatives. We get 1 and we get 0. And now over here, we're taking v prime to equal e to the minus st. Okay, and then we integrate this. And as we've shown before, when you integrate this, you get a minus s. Okay, see? So you're treating s as a constant, minus 1 over s, e to the minus st, okay? Then you put it back into this formula here, okay? And don't forget, you're doing the limit on everything over here. So all this now is part of the limit. So here we go. We have the limit as b goes to 0 of this first one, and this will be, you're bringing this down, you're multiplying the t times this, but this will be plus, okay, on the first run. If you had a second one, you could do by charts, not by parts, and you would just keep going. But uh, and you're going to see we're going to do that Well, not quite. We're not doing by charts today, but I probably could have. So we're just going to run it back into this integral here. All right, so u is t. So there's my t. V is right here. E, oh, what is this? This should be v prime. Is that, did I make a mistake? U, v prime. Okay, so I guess this is v prime. All right, so then times minus, okay, e to the minus st over s, all right? And as we've shown before, as you approach, as b approaches infinity, okay, as b approaches infinity here, you're going to, the t, so this is your t, right? This is going to go away as we, uh, because it's going to get smaller and smaller to, and eventually in the limit goes to 0. So that's gone. Now we're minus the v, okay, which is the minus e to the minus st. Okay. Oh, yeah, yeah. This is v, not v prime. Sorry, it's v. Okay, so it's v times again the minus e or minus st over s. Okay, times 1, which is u prime. Okay, so there it is. And following the definition, this whole thing is minus, so you have two minuses. Okay, so there we are. So far, we're facing another integral. Okay, but don't forget the limit is still out here. You have to apply the limit uh, to that part as well. Okay, so as we continue on, um, we already did this integral. This is the Laplace of 1. And what did we find? Right? We found that it's 1 over s, right? So we have 1 over s. We pull that out front, and then we got this integral here, which is going to be e to the minus st, right? So, and times 1, and that gave us 1 over s. So we have 1 over s times 1 over s, where s is greater than 0. And the result, like I said, is you're pulling this out, and then the result of this part here is the 1 over s. It's already repeated. This is our first video, okay? The constant, taking the Laplace of 1. All right, so, and the Laplace of 1 is 1 over s, and we have this out front from our work on the prior page, and then we get a solution 1 over s squared. So there you go. The Laplace of t, okay, is 1 over s squared. And there you go. Thank you.